All right, so good morning, everybody. We are going to be in this lesson. This is part two, section one, and we are using rates and proportional reasoning to solve real world problems. So, in this case, we're going to be dealing with actual things that could happen in real life, okay? So, to get us started thinking about ratios and rates, who can give me an example of a ratio?
Four thirds.
Layla, will you read this?
A ratio is an association of two or more quantities. This example shows three red chips for every two chips. The ratio of red chips to blue chips is 3 to 2. This ratio can also be written as 3 to 2. In some situations, ratios may be written as
Quotients?
quotients such as 3 over 2.
Correct. All right, so based off of this, let's come up with some examples of ratios.
Can I say? Can I say one?
Sure.
Um, 4 bags of chips for every 3 watermelons.
Perfect. All right.
I know one, Mr. Meyer.
All right, give me one, Jamal.
I got 3 phones and 6 chargers.
Okay, so 3 to 6. Emma, what were you going to say?
I didn't mean to unmute my mic, but I can say one.
Yeah, go for it.
Okay, say you have 6 dogs and 10 cats.
Perfect. All right. So those are some perfect examples of ratios. So who can give me example of a unit rate? Who remembers what a unit rate is?
Like miles per hour.
Correct. So it says that a unit rate is expressed as a quantity of one. So it says the unit rate is 37 miles to 1 gallon of gas. Or you could say 37 miles per gallon. So just like Najela said, she said miles per hour. So she gave us a perfect one. Does anyone else have another one that we could use? So basically, it's a ratio that's being compared to a unit of one. So like miles per hour, miles per gallon. What's another one?
Miles per paints.
Yeah, that would work.
Miles per days.
Correct. Mile per day. All right. So any of those would work. Those are perfect. All right. As long as it's referring to 1 day or 1 gallon or 1 pint or 1 hour, one whatever. All right. It's a certain number that's referring to something to one. Okay.
So even 1 millisecond.
Correct. As long as it's like 2 to 1, 3 to 1, 4 to 1, 100 to 1, 2,000 to 1. The one of them has to be what?
One.
One. All right. So we're going to go back and we'll get started. Has anybody ever seen a ratio or a rate used in real world? Like just in everyday?
No, sir.
You hadn't? What about whenever you go by the gas station and it says uh, $2.56 per gallon? Is that a rate or a ratio?
Yes.
Yeah, it is. It is. What about whenever it says you can get uh, like 2 candy bars for $1.50? Is that a ratio?
I ain't never thought of it. Yeah.
Mm-hmm.
It's a ratio.
Yeah, a lot of times stuff like that's right in front of us, but we don't recognize that it is, you know,
Yeah, just like a honey bun, you can get 200 buns for $1.
perfect. Perfect. explanation. All right, so we're going to get started with what we have, and we're going to look at this first page and look at the three panels that they give us. All right. So let's get Emma to read this for us. Emma, will you read this, please, ma'am?
It says, in the last topic, you learned that ratios and proportional reasoning, about ratios and proportional reasoning. This animation will help you to review these ideas. Artists use proportional reasoning to create accurate scale drawings that are not distorted.
Good. So we're going to play this. So what's he doing here? Somebody tell me what they just did. What'd they find?
The height and width of the boat.
That's right. And they did that of the actual, and then what did they do to make the drawing?
Divide.
You're right. What did they divide them both by?
Two.
Correct. So the picture is half the size of the actual boat, right? No, I'm just kidding. Look at it closely. It looks like it would be. Yes, it's way bigger because we're working with inches now in the drawing, not what?
Feet.
Yeah, so there's really a big difference. All right. But is that a scale drawing though? Yes or no?
Yes.
Yeah. All right. So it says, read that for us, please, Halen, in the yellow.
Oh, a key characteristic of scaled images is that the quotient of the height and width of the boat in the picture is equal to the quotient of the height and width of the actual boat. The equation showing this character is called a proportion. A proportion is a statement of equality between two ratios and is often written as an equation.
All right. So when we were talking, we said that, if you do 30 divided by 2, you get 15. But if you look at this, they're actually going from feet to inches. So it's a little bit more complicated than what it looks like. And I feel like we're going to get into that very soon. Okay. So let's look at number 2. All right. So what's taking place here? Walk us through this. What's happening, Najayla?
They're multiplying by 4.
Hold up. Najayla, what's happening in this?
They're multiplying by 4.
All right. But so what did they do to the original image? Did they multiply just one part by 4? Did they multiply both parts by 4?
They multiply length times width by 4.
All right. So they multiplied the length by 4 and they multiplied the width by 4. And when they did that, what happened?
They got a big picture. Oh, my bad. It reduced.
I can't hear. What happened to Jayla?
It reduced.
All right. So she thought that it reduced. Do we agree or disagree with her? Is this image right here a reduction of this image?
Wait, does reduce mean get bigger or?
Reduce means that it gets small, and enlarge means it gets bigger.
Oh, yeah, enlarge.
All right, there we go. Good job, girl. So if it gets bigger, it is enlarging. Okay, and so she said that this enlarged because it's 4 times the size of the original picture, right? Y'all gotta participate with me. Yes, it is. Thumbs up, something.
Yes.
Thank you. Yes. All right. So let's see if I can get some help from some other people real quick. Keegan, will you read what it says down there in the yellow, please?
The mic thing's coming up. It won't go down.
Uh-oh. What about now?
Okay. In this example, the height and width of the larger picture of the giraffe are 4 times greater than the height and width of the original.
All right. So is that exactly what Najela said just a second ago?
Yes.
Yeah, it is. Good. All right, let's look at part 3. We ought to remember this. We did this in the first one, didn't we? Lainey, tell us what's going on here. What are they doing to find this measurement and this scale? What are they doing?
Multiplying.
All right, explain it.
They're multiplying 68 times 8.
All right, so if we do 68, if we do 68 times 8, we get this big old number. Is that what they did?
You gotta divide.
Yeah. All right, so Lainey, tell me what you think we're going to do. What did they do?
They divided 68. They divided by 68 and 8.
That's right. All right. And so the reason that they did that is because they're trying to find the height that they should make this. So we're doing 68 divided by 8, just like Lainey said, and we get 8.5. Now, since we found that the scale factor is 8.5, Lainey, what would you do to determine what this measurement would be? What would you have to do? So right now it's saying that if you take 8, which is the width of this, and multiply it by 8.5, it gives you 68 inches. So what do we need to do to figure out what this height would be from here to here? What would we need to do?
Would you do 8.5 times 10?
You are 100% correct. That's exactly what we would do. So if we take 8.5 times 10, what's our new height going to be?
85.
85 inches. Good. So read that for us, Jamal. What's that say down there at the bottom?
Well, on my mic, you know, this scale is the
Quotient?
Quotient of the corresponding dimensions in the scale image of the original image.
All right. So what does quotient mean? What is a quotient? Does anybody know what a quotient is?
The answer.
Good job, Makai. The answer to a division problem is a quotient. Good job, man. All right. We're going to keep on moving. We're doing good. All right. Let's see, though. There was one question that was asked. It said, use panel 3 to review finding the scale factor given 2 scaled images. And we're supposed to answer question 1 in our workbook. So what page are we in our workbook? Wasn't it 43? I think that's what Jacaden told us last week. We were going to be in page 43. So everybody look at their workbook in page 43 and see if we can answer question number 1. Excuse me. What does question number 1 say?
Find the scale factor between the two images.
All right. So what was the scale factor?
4.
The scale factor for this was 4?
8.5.
How did we get 8.5? What did we have to do?
68 divided by 8.
That's right. 68 divided by 8 gave us our scale factor, and the scale factor was what again?
8.5.
Good. So everybody should have that written down in their book. Number 2. Let's see. Reginald, read this for us, please, sir.
Yep. We what?
That page where it starts with in your previous work.
In your previous work, you learned how to express relationships using ratios. Use this picture to review what you know the ratio is of its height. 2 is width to 3 inches to 4 inches. Every ratio has 2 associated
Associated rates.
In this case, you could think of the rate that compares height to width. 3 inches of height of every 4 inches of width. You could also think of a rate that compares width to height, 4 inches of width for every 3 inches of height.
All right. So looking at this, it says a unit rate is a rate in which one of the numbers being compared is 1 unit. That's what we talked about at the beginning of class. It says you can express the relationship you see in the giraffe picture with 2 unit rates. We could say that 3/4 of an inch in height per 1 inch of width, or we could say 4/3 inches of width per 1 inch of height. So either way, those are both what's?
Unit rates.
Unit rates. Good job. They're unit rates. All right, so it says use this page 2 to answer questions 2 and 3. So what does question 2 say on our workbook?
I can read it.
Say that again, Jamal.
We on page 44.
We're on the question right after the one that we just did that asked what.
I don't see no 2. That's why I asked.
It go from
page
43, bro.
One. No, the first question is the thing. That question 2, define the unit rate. We already did that. We on question 3.
Okay, so we were supposed to say what the unit rate was. So we need to put the answer what a unit rate is. What is a unit rate? What is a unit rate?
A unit rate is a rate in which one of the numbers being compared is 1 unit.
Great job, Hayden. Hayden, I want you to read what a unit rate is.
I don't know. That's why I need her to help me.
Do you see it highlighted?
Oh, a unit rate is which a number, where? On my page?
Right here.
On the screen.
On the screen.
On the screen.
Oh, a unit rate is which one of the numbers being compared is a 1 unit. Why y'all laughing? I'm gonna talk about it more.
You got it now? All right. Y'all embarrassed you, Caden. All right, here we go.
He always be doing this stuff. He be doing it on the game, too.
Oh, goodness. All right. So what was the third question Rosiah, what was the third question?
In my notebook.
Correct.
In my notebook.
Correct.
Express the relationship between the height and width of this picture as a unit rate.
All right. So we got to basically say in words what it is. Okay. So how are we going to use this as a unit rate? How do we say that?
Wait, what's the question?
We have to express the giraffe picture as a unit rate. So we either have to say height to width or width to height. And we have to express this in a way that it sets it equal to 1. So what could we say?
We on question 3, right?
Correct. And it tells us what to do right here.
You can express your relationship using giraffe picture with 2 unit rates.
All right. So say this one for us.
Which one, the top or the bottom?
Top.
All right. 3/4 inches height per 1 inch of width.
Okay, so that's one of our answers. So everybody should have that for number 3. Militon, what's the second answer?
4/3 inches of weight
Width.
of width per 1 inch of height.
Good. All right, Jemiah, Warren, what should our answers be for number 3? What should we have put in number 3 in our workbook? What do you have, Jemiah? Jemiah.
I think she's asleep.
I can't see her. I've been to.
I can't fit all that on my
Yes, you can.
Cause don't we got the right inch height?
Jemiah, I can't see your face. If I can't see your face, you ain't here. You're going to be marked absent. You already got a lot of absence. That would not be good.
What if our camera and her mic broke and she just can't say anything?
Well,
What if that happened?
that's no bueno. She better come to the school and get another computer.
No bueno.
Yeah, no bueno.
No, she can text in the chat,
that means no good.
You make me want to learn Spanish.
That's right. I'm going to teach you a little bit. No bueno means no good.
Oh, I know a Spanish word.
Boy, no.
I know,
I know one word and it's C.
Here we go. All right. So let's move on to this next question. Y'all are doing great. What's our next question say in the book?
A recipe for oatmeal calls for 1.5 cups of oats and 2.5 cups of water. Find the 2 unit rates associated with the ratio.
All right. We finna make that happen. Look at that good oatmeal. Yum. That
Why that looks so disgusting?
I was thinking the same thing.
It looks like cereal.
I couldn't eat
Well,
that.
for real, that do look like cereal. That look like for rice.
I'm worried about the spoon. Why does the spoon look like that?
I think.
No, that's some Rice Krispies.
I don't know what that is.
But this how them Frosted Flake covers.
But I tell you what, if you eat that, you're gonna look like Arnold if you're working out, because that is some healthy food right there. All right, here we go. Y'all probably don't know who Arnold is. Y'all know who Arnold Schwarzenegger is? The big dude with the big muscles? Yeah.
I thought you were talking about Hey Arnold.
No, Arnold, like off Terminator.
Man, I'm gonna be like Sylvester Stallone.
Yeah.
Way bigger.
Yeah.
Yeah,
But Sylvester's smaller than Arnold.
That guy was on a toy called Stretch Arnold.
Arnold, I thought you were talking about
Arnold
Big
Arnold
Arnold.
Schwarzenegger, he's from Austria.
Yeah, Germany.
Oh, I thought they said Austria or something.
I'm pretty sure he's German.
What's his name again?
Arnold Schwarzenegger. He's
That big dude.
he's the big dude on Terminator. At the end of the show, he's like, "Hasta la vista, baby."
Yeah. Look, he be like, I'll be back.
Yeah. All right, let's read this one. Number 3. Read this for us, Zayden.
Unit rates can be useful in scaling recipes. You have already used the proportional reasoning to solve problems involving recipes. This animation shows you how to use unit rates to scale a recipe for oatmeal. Oh, that is oatmeal. To make oatmeal, you need to heat a combination of water and oats. The recipe calls for 1½ cups of oats and 2½ cups of water.
All right. So let's see what happens when we play this. All right. So they put 1½ cups of oatmeal and they put it in to the pan on the stove. Then we put 2½ cups of water.
Why did oatmeal like a cereal box?
Well, some oatmeal looks like that.
In a cereal box.
That's how oatmeal look.
Oh my god.
Like some of them look like
But
some of them come like that kind right there. That oatmeal, that's the healthy oatmeal. It ain't got nothing in it.
Yeah, that's the one
If
that
you
got
if you get the oatmeal that tastes good, it comes in a little box.
I don't eat oatmeal.
Talking about with the little packs in there.
Yeah.
Man, this one you got right there. This one.
All right, so look at this. It says there are 2 associated unit rates for any ratio. All right, so what are they doing right now? What did they just do?
Look like they added them up.
Did they add? They're on top of each other. They're on top.
Did they divide?
Good job, Halen. They divided. And so they did 1 1/2 divided by 2½ to get 1 cup of water. And whenever they have 1 cup of oats, they're doing what?
Dividing.
That's right. They're doing the cups of water divided by the cups of oats. So tell me this. When it says there's 2 unit rates, because you can compare the 2 quantities in different orders, what are our unit rates? This is going to be the answer for the question that Jacaden read for our book. So what would be the unit rates? Remember, a unit rate is just a ratio that's compared to one part. And so they gave us 2 of them right here. So what would they be?
2 1/2. No.
You're starting off right.
1 1/2.
You're starting off right.
1.
Yeah. 1 1/2 and 1.
All right, so look. This would be oats to water. And this is saying this is the cups of water to the oats. So this right here is a ratio, and this one right here is a ratio. But they're both what type of rate, since they're being compared to one whole? Unit rates. All right? So see if you can answer the question now. How do we say that?
Oh, 1 1/2 and 1 1/2.
Close.
That's
1
2 1/2.
correct.
What the heck?
1 1/2 over 2 1/2 to 1.
What the heck?
So remember, we're doing cups of oats to cups of water for this one, All right. Same thing here. Cups of oats to cups of water. So tell me what our 2 unit rates would be.
1 1/2 and 2 1/2.
1 1/2 over 2 1/2 to what?
2 1/2 over 1 1/2.
To, what's it got to be to? What are we comparing that to? For it to be a unit rate, we're comparing it to what, Jacaden?
1.
Good. All right. So our 2 rates, what we should have is 1. I'm going to just put 1.5 over 2.5 to 1. That's one of them. All right. So that's number 1. Now we need number 2. What would number 2 be?
That don't make no sense.
It does, because it's right here.
How they equal 1? They equal more than 1.
All right. So what it's saying is if you do 1 1/2 divided by 2 1/2.
Mhm.
So let's do that real quick. Let me get all this off of here. All right, so we're going to put this in the calculator. 1.5 divided by 2.5. So we get 6/10. So 6/10 of oats to 1 cup of water. So if you put in 6/10 of oats, you're going to use 1 whole cup of water, is what that's saying. So that's what this is. Like once you work this out, this is 0.6. This equals this, in other words. So that's saying that 6/10 of oats would be used with 1 cup of water to make the oatmeal taste right. Right or wrong?
Man, I have no clue.
All right,
Right.
let me put it another way. 6/10 is actually 3/5 cups. Okay, so that's saying 3/5 cups. That looks like caps, but 3/5 cups of oats is used to 1 cup of water. So ugly. That's water. Looks like wafer.
Dang.
Y'all know that water in Spanish is called agua.
Agua.
yeah.
Agua.
Like aqua.
All right. Now, so the same thing would happen here. If we had 1 cup of oats, there would be how many cups of water?
1.
Well, we got to see. Look at the difference. The difference here is 2 1/2 is being divided by 1 1/2. So we got to put that in the calculator, and we'll see what that gives us in a decimal. So we're going to go 2.5 divided by 1.5, and we get 1.6. So this is actually 1 2/3 cups of water to 1 cup of oats.
I'm lost.
That's okay.
You started explaining and then I got lost.
It's okay. All right. We're going to do some that are easier than this because this is kind of a hard one, okay? So let me get us a different problem. Let's see what's on the next page and see if they give us an easier one. If they don't, I'll give us an easier one at the end of this. So basically all we needed to do to answer this was we just needed to write this for our answer and this for our answer. So we need to write both of those and just put our colon in between them. So this is a ratio and this is a ratio. So that needs to be written down in our workbook.
Hold on, keep that up there, Mr. Meyer. I lost my pencil.
It's all good. I'm going to play this, see if it helps us.
That don't make no, like, how do you even get 0.6 from?
I just divided it. But look what's happening. So they're taking 1 1/2 cups of oats and they're dividing it by 5 seconds cups of water. And they're going to see what it equals.
Mr. Meyer, take it off.
Isn't that what I got a while ago? 3/5 cups of oats per cup of water?
Yes, sir.
Yep. All right. So that's a good one we can write.
No,
Yep.
Timmy, your mic.
And let's see what it'll be the other way. I think we said 1 2/3 cups of water to 1 cup of oats. Let's see if that's what they get.
Why we gotta do all this just to make some oatmeal? Wait. Thank you. Like, all you gotta do is read the stuff on the back, put it in there, put it for how much water, throw it in the microwave. Shoot, oatmeal not even that good.
You are so goofy. All right. So they put 5/3 cups of water per cup of oats, but 5/3 is actually 1 2/3 cups of water. All right. Per cup of oats. So that's exactly what we came up with. So these two right here, we need to write these in. Makai, mute your mic. My goodness. All right. Anyway, so we should have 3/5 cups of oats per cup of water, or 5/3 cups of water per cup of oats is what we should have. All right, let's move on to page 4. See if it's an easier one. If it's not, I'm going to come up with one ourselves here in a minute.
It better be an easy one.
Whenever they throw those complex fractions, it kind of throws us.
Oh, that don't even look easy.
Yeah, that's not easy.
It's going to be
It's gonna
easy.
be hard.
All right.
We doing grown folk stuff.
That's all right.
Oh my god.
All right. Let's see. Read this for us, please. I'm going to give Raziah another chance. Raziah, are you there? Nope.
Yes, sir.
All right. Read this, Raziah.
The top paragraph.
Yes, ma'am. All that.
Unit rates are especially helpful when you are planning to take a trip when traveling by car. It is important to know your car's gas mileage or how far it can travel on 1 gallon of gas. Miles per gallon is another example of a unit rate. Another common unit rate is speed or average miles traveled in 1 hour. A unit price is the price for one item. For example, suppose you purchase picnic supplies in different size packages. If you want to know the price of one setting, you need to find the unit price. Picnic supplies for 30 people. Plastic silverware box of 15 cents, $4.50. Paper plates box of 10, $2.40. Cups pack of 5, $2.
All right. So it says in this topic, we're going to continue to explore the rates and proportional relationships, and we're going to learn more about unit rates, and we'll see how they connect to ratio and proportional reasoning. All right. So let's look at question 5. What does question 5 state in our book?
What are some examples of unit rates?
All right. So could we find unit rates based off of what they gave us for the picnic stuff? Okay, how would we find it? How would we find out what one piece of silverware cost? What could we do?
That I don't know.
Well, if 15 costs $4.50, how could we find out what one would cost? We would do $4.50 divided by 15.
I can see this question. Where are they at that it becomes that small? Because you go to the dollar store and get a pack of 100.
I have no idea. So check this out. Well, I guess it's, man, don't get me lying. This is kind of expensive. This right here is 3/10. 3/10 would be 3 tens. So how much does one piece of silverware in that box cost? How many cents?
3 cents.
Nope.
3 cents.
Nope.
$3.
Nope.
Oh man.
Remember, this is
Oh, you said 3 equals
3.
10 cents.
That's 3/10. So that would be saying 3 10-cent pieces. So 10 cents plus 10 cents plus 10 cents, 30 cents. Good. So
So that means 1 cent equals 1 cent. That means 1 cent equals 1 cent.
Hey.
what?
That means 1 cent equals 1 cent. 1 plastic.
All right, but look, this is,
Hold on, Jay. Hold on, Jay.
all right, this is in the tenths place. If it would have been in the hundredths place right here, then it would have been 1 cent.
Oh, I get it now. 30 cents for 1 plastic fork.
Correct, Jacaden. So we would say that if we were putting this as a unit rate, we would say that it is 30 cents per what? Yeah, sounds good. 30 cents per fork or 30 cents per plastic silverware piece. All right. So is that a unit rate? Yeah. All right. Tell me another way we could find a unit rate out of something else they've given us. What could we do? Okay. Tell me what the same thing is. Well, we already found the paper plate. Yeah. So let's find the paper plates. What would we do?
Divide.
All right. Tell me what to divide. Tell me what numbers to do.
Yeah.
Say it again.
10 divided by $2.40.
All right. So if I do 10 divided by $2.40. So one plate costs $4?
God dang.
Hey, that's expensive.
Do you think that's right? Because it says that a box of 10 costs 2. So how does one plate cost 4? That's not going to work. What do we need to do? No, think about it. I don't think we divided right.
You have to do $2.40 first.
Good job, Najela. We got to do $2.40 divided by the number of plates. So anytime we're trying to figure out what something costs, we're always going to do the dollars divided by the number. All right, so when we do that, we find out that each plate cost how much?
24 cents.
All right, so tell me that in a unit rate. Tell me that in a unit rate. What would we say?
Each paper plate is 24 cents.
Okay, so that is a unit rate. Or we could say 24 cents per plate. Good. All right, so let's try this last one. I want y'all to try this last one. Somebody beside Jamal, Jacaden, Najela, tell me how to do this. Halen, somebody tell me besides those how to do this because they've been working hard this whole time. So I'm looking to hear from Laney, Layla, Militant, Najela, Raziah, Reginald, Sarah, Tashandra, Zayden, Layla, Laney, Azamian, Deonti, Makah, but he's been working too. Somebody tell me, what do we need to do to find the unit rate of the cups? What would we do?
Multiply.
What am I multiplying?
Everybody older than this. But 4.50. And is that 15?
Well, we're right here now. We're on the cups.
$2.
What am I doing with $2?
And you multiply them.
All right, if we multiply them, is that going to find the unit rate?
I don't know. That's what I'm trying.
Please, Mr. Lawrence.
Help him out, Jamal. Why will that not find the unit rate?
$2.
Divided by 5.
Why do we have to divide instead of multiplying?
Because if you multiply, it wouldn't really turn out right.
Yeah.
A whole bunch of just for one cup.
It would cost too much, wouldn't it? So this is telling us that each cup costs how many cents?
4. I really want to know where you gonna go get a 5.
Say it again. I think Najela said it.
40.
40 cents. That's correct. 40 cents.
Jesus Christ! I just really want to know where you just gonna pack a 5.
For one cup, it's 40.
This must be like the party cups. You know, like the ones that look kind of nice.
They look nice, but they aren't.
Yeah, they're gonna break, but they look nice.
If you squeeze it, something goes pop.
Yeah, it's gonna break. All right, so 40 cents per what?
Cup.
Per cup.
Per cup.
All right. So, in closing of this, what are some unit rates that we can use to describe our class or things in our class? What could we say? What could we use as a unit rate in our class? So there's 25 students in our class per what?
Per one teacher.
Per one teacher, per class. Those both work good. So would those be unit rates? Sarah, is that a unit rate?
Yes.
Yeah, because we compared all 25 students to one what? One teacher or one class. Okay. All right. So our assignment for today is to finish questions 6 through 10. So I want everybody working on 6 through 10. We're going to check these tomorrow at the very beginning of class. All right. So everybody needs to work these in their books. Can everybody do that?
Yes, sir.
All right, everybody do that. We're going to check these first thing in the morning. Well, guys and girls, I hope y'all have a fabulous day. I enjoyed visiting with y'all and learning, and I will see y'all soon.